Yes, listen carefully, dear all students. What is work? Work means is the form of energy. Is the form of energy. Work is the form of energy, and it is defined as the work can be defined as the displacement of an object. Displacement of an object against to the force. Displacement of an object against to the force is called as a work. So according to that, work is equals to force into distance or displacement. The distance place you can write displacement also. Force F, we know very well that force F is equals to pressure into area, means external pressure into area. Okay, so that W is equals to external pressure into area, and distance, small change, means the object is displacement. How much displacement? It is defined as the dl. Displacement or distance moved by the object is dl, and against to the force, and force is nothing but P into A, means pressure into area. So we know that area into distance, dl, is nothing but change in volume. Change in volume. So this change in volume we can write dv or delta v also. So both symbols are same only, dv or delta v. Okay, now this formula we are converted into W is equals to external pressure into A into dl. This A into dl is nothing but dv. Okay, then pressure into dv. So now in our chemistry mechanical work, we need to discuss about that mechanical work Iupac convention. According to Iupac convention, that mechanical work is the negative sign, of the pressure into change in volume. Mechanical work is the negative sign of pressure into change in the volume. So you have to remember. So that work is equals to negative sign of pressure into change in the volume. That's why finally what I am writing, that work formula W is equals to minus P into dV or delta V. P into delta V, where delta V is equals to change in the volume, final volume. So delta V is equals to Vf minus Vi. Okay, students, you have to remember. Now we need to discuss about some conditions. Work is two types of works are there. One is work done by the system, and second one is a work done on the system. Work done on the system. Okay, now it's very clear, dear students. Work W is equals to, the mechanical work is equals to negative sign of pressure into change in the volume, delta V. Okay, it's very clear. And delta V is equals to volume, final volume of the system minus initial volume. Okay, now you have to imagine. So during the compression, means the system, like you have to take one piston, closed system you have to take. Okay, now like this is one closed system. This system is completely closed by without gravitational force, containing one piston you have to take. This is the piston. Now during this first point, compression means we are using some external pressure. So in this compression process, P external pressure is more than internal pressure. Then this is the initial volume Vi. Now during the compression, what happens? This piston will be moves. Okay, this piston will be moves, and it will comes to like this. This is the final volume. This is total is initial volume, and this is a final volume. So during this compression of a system, compression means some external pressure is working on the system, then the external pressure is more than the initial pressure of the system, then the initial volume is more than a final volume, then the delta V is equals to negative. If the delta V is negative, means work, this is negative of negative becomes positive, then the work is becomes positive. If work is positive, means such kind of work is called work done on the system. Work done on the system. This is example for work done. Work done on the system. Work done on the system. So during this work done on the system means compression. Compression. Then delta V is equals to negative, sorry, delta V is equals to negative and work is equals to positive. If work is equals to positive, it is called as work done on the system. Now reverse. Let's see that reverse. For example, you have to take one piston, one closed system. Now here the piston is present. Now this is the initial volume Vi. Now in this case P internal pressure is more than external pressure, then the compression will be expand. Means if the expansion means it will be moves like this, compression will moves, then it is called final volume. In that case, in that expansion of a system, the final volume is more than initial volume. Final volume is more than initial volume, and delta V is equals to positive and work is equals to negative. If work is negative means it is called as work done by the system. Work done by the system. Okay, so you have to remember 2 points only. Just whatever all these diagrams, if you are remembered or not, it's not a matter. Just you have to remember, dear students, that work is equals to minus P into delta V. Okay, if delta V is positive, if delta V is positive means compression, then the work is positive. If the work is positive means it is called as work done on the system. Work done on the system is positive. Then delta V is negative. Work and delta V, change in the volume, both are opposite signs. You have to remember, it's enough. So work done on the system, work is positive, then delta V is negative. W is positive and delta V is negative means it is that work is called work done on the system. If delta V is positive and work is negative, then that work is called as work done by the system. Work done by the system means expansion. Work done on the system means compression. Work done on the system means compression. Okay, so these 2 formulas you have to remember, and these signs and all will be helps in first law of thermodynamics. Okay, students. Yes, listen carefully. Next, what is heat? What is heat? Heat is nothing but it is the form of energy only. Heat is nothing but is the form of energy, and heat is defined as the flow of temperature from one system to another system. Means it indicates that it flows from one system to another system. Means system to surroundings or surrounding to system at different temperatures. The flow of heat means it flows. The heat will be flows from one system to surroundings or surrounding to system at different temperatures is known as a heat. Okay, heat means heat is nothing but is the form of energy. It flows from one system to another system at different temperatures is known as a heat. According to the Iupac convention, if a system absorbs heat, means heat absorbed by the system, then that it is called positive. Then heat Q is a positive. If Q heat, the symbol is Q, either small q or positive q, whatever it may be, no problem. Q is positive sign is there means it indicates heat flows from surroundings to system. Heat flows from surrounding to system means system absorbs heat, brackets, system absorbs heat. If system absorbs heat, then the Q is positive. Q is positive means the heat is flows from surroundings to system. Heat is flows from surroundings to system. Next, if Q is negative, when the Q will becomes negative, dear students, the Q is negative means it releasing heat. It is a releasing heat. It indicates releasing heat. The heat is releasing or heat is flowing, releasing from or flowing from system to surroundings. System to surroundings. So you have to remember that. So heat is a form of energy. It flows from one system to another system, or one system to surroundings, or surroundings to system at different in temperatures. If heat is positive sign, if Q is positive sign, it indicates the absorption of heat. Absorption of heat means the system is absorbing heat. How the system is absorbing heat? It is absorption from surroundings. Means the heat is flows from surrounding to system. Surrounding to system. Okay. Next, if Q is negative, if Q is negative, negative sign means what it is, dear students? It releasing heat. Which is releasing? The system is releasing heat. If the system releases heat, then the Q is negative. It indicates that heat is flows from system to surroundings. Heat is flows from system to surroundings. Okay, is very, very important. Now let's see that first law of thermodynamics. What is first law of thermodynamics? So mainly this first law of thermodynamics is also called as law of conservation of energy. Law of conservation of energy. Law of conservation of energy. Already law of chemical in some basic concepts of chemistry there we are discussed. Chemical different laws. Law of conservation of mass and law of definite proportions, law of reciprocal proportions and all. So the first law of thermodynamics is nothing but one type of law of conservation of mass or law of conservation of energy. Mass is nothing but is form of energy only. So the first law of thermodynamics is also called as law of conservation of energy. So what is the statement of law of conservation of energy? Already you know that law of mass action or law of conservation of energy is nothing but energy is neither created nor destroyed. It can be transferred from one form to another form. It can be transferred from one form to another form. Means energy, how much energy is absorbed, the same quantity of energy is released to another system. Of how much energy of one system is released, that energy will be absorbed by another system. Means the energy is converted into one form to another form, but it cannot be destroyed. Is known as a first law of thermodynamics. Different statements, man. So define first law of thermodynamics means you can write any one of the statement, but mathematical equation it must should be unique. So by using that mathematical equation, different conditions we need to remember. Those all conditions are important for objective examination. Okay, students. So another definition: the loss or gain of energy by the system. Okay, for example, system. You think system and surroundings. Surroundings. Okay, now the energy is lost by the system. If system loss energy means that can be gained by the surroundings. Means if system loss means the energy can be gained to the surroundings. If system gains energy means the energy will be lost by surroundings. If surrounding loss energy, then that energy will be gained to the system. Means the energy is exchanging between the system to surroundings and surroundings to system. Means the loss or gain of energy by the system is must should be equal to the gain or loss of energy by the surroundings. Okay, students. So both are equal, like saying. Means energy is not destroying. That energy is converting into one form to another form. Means the energy is transferred from system to surroundings or surroundings to system. How much energy lost by the system is equals to same amount of energy gained by the surroundings. If how much amount of energy lost by the surroundings is equals to the same amount of energy gained by the system. That is also another definition for law of thermodynamics. And another important definition, the mechanical definition of first law of thermodynamics is it is impossible to construct a perpetual motion mission, a perpetual first kind of motion mission without consuming any form of energy, without consuming any form of energy. So it indicates, it is a simple logic, dear students. For example, any mission, so in order to work mission or any system, initially some energy it need to utilize. Means 100% efficient mission we cannot construct. We cannot construct. It is impossible to construct a perpetual motion mission of first kind that can work without consuming any form of energy, without consuming any form of energy, like say. Okay, it is also the important definition for first law of thermodynamics. It is correct only. For example, motor bikes are there. If you want to start that motor bikes, means initially we need to consume some amount of energy, then only that inside fuel will be that combustion takes place and gives energy. And also that mission, whatever the mission is there in that motorcycle, and its efficiency is not 100%. So is less than 100% efficiency only present. So 100% efficient mission still we are not constructed. Even it is possible in cyclic process, it is possible. Cyclic process it is possible, but it is theoretically only it is possible. Practically it is impossible to construct such kind of missions. Okay, students. So now that mathematical form, how to derive that mathematical form for the first law of thermodynamics. For that statement, this also we can define as the net energy change in a closed system. In a closed system, net energy change is nothing but internal energy change. Net energy change in a closed system is nothing but internal energy change is equal to the heat absorbed by the system plus work done by the system. Means the net internal change in a system is equal to how much amount of energy absorbed by the system plus after absorbing the energy by the system what will do? System will do some work, that is called work done by the system. So the mathematical form of first law of thermodynamics is equals to the internal energy change in a closed system is equals to the sum of the amount of heat absorbed by the system plus work done by the system, means Q plus W, where delta E is equals to internal energy change and Q is equals to amount of heat absorbed by the system. So here Q is positive and W is equals to work done by the system. W means work done by the system, So in for board examination, they will ask define first law of thermodynamics. First law of thermodynamics definition they will ask, and write mathematical equation. So above I said 4 different definitions. I said any one of the definition you have to write, and mathematical equation means delta E is equals to Q plus W, where delta E is equals to change in internal energy and Q is equals to amount of heat absorbed by the system, and W is equals to work done by the system. Okay, it is the mathematical form of first law of thermodynamics. So by here, how many variables are present, dear students? One is internal energy change, the second one is heat Q, and third one is work. So different conditions, like 3 variables are there, and 3 from the above equation, first law of thermodynamics equation, we need to discuss about 3 different conditions or different cases we need to discuss. In that all cases, how that internal energy and Q and work is related, mutual relations we need to discuss. In that 3 variables, one variable becomes constant or 0, and what is the relation between the another 2 variables we need to discuss. Okay, students, listen carefully. Discussion on the equation. Now let's see the first condition. So the equation is what, ma, dear students? The delta E is equals to Q plus W. Okay. In this equation, already I said three important condition will comes. The three important conditions, one should becomes constant, and what is the relation between the another two in a system. In a system, we need to discuss. For example, when W work is 0, the W means work. Work is two types. It may be either work done by the system or work done on the system, whatever it may be. If work is 0, then what happens? The internal energy change is equals to Q. Means if Q is equals to this, we can write also like this. Q is equals to delta E. Okay, students. If Q is equals to positive, if Q positive means what it is? Heat absorbed by the system. Heat absorbed by the system. After if system absorbs heat means what will do? It will do some work. Then if Q is positive, then heat absorbed by the system. Then W also what happens? If Q is positive, then Q is equals to delta E means delta E is also positive. Delta E is also positive. Then this heat will be utilized to increases the heat absorbed by the system is used to increase internal energy. Internal energy is used to change in its internal energy. Means if Q value increases, if Q is positive, then Q value is increases, then delta E value also increases. If system absorbs heat, then the internal energy increases because Q and delta E signs both are same. If Q is positive and delta E is also positive sign. If Q is negative, the system releases heat. Then internal energy, what happens? If there is no energy in your body, there is no energy. Then what happens? You becomes very dull. So your body becomes very dull. Means there is no internal energy. Internal energy also gradually decreases. For example, your body gains some energy. Then automatically that energy will be utilized to increasing your internal energy. Then you becomes very active. Okay, students. So the second condition, let's see. If heat released by the system, if heat is released by the system, if heat is releases means Q is equals to negative. If Q is negative means delta E is also negative sign will comes. So if heat releases, then W is constant, W is 0. In that case, we are discussing about the relation between internal energy and heat. So if heat is released by the system, then internal energy will be decreases when work is constant. W is equals to 0. So you have to remember. Next, second condition, Q is 0. Already we have discussed that thermodynamical process, Q is constant or Q is 0 means it is adiabatic process. In adiabatic process, Q is equals to 0. Then the remaining relation delta E is equals to W means both are same sign. If work W is equals to positive, then delta E is equals to positive. Means W is positive means what it is, dear students? Work done on the system, work done on the system increases delta E. Increases delta E means increases internal energy. Okay. Next, if work is negative, second condition, let's see. Work is negative means what it is? Work done by the system. Then internal energy, what happens? Then delta E is decreases. Means internal energy decreases. Internal energy decreases. So if Q is equals to 0 in adiabatic process, if the system means work done on the system means some work is going on the system, then what happens? Internal energy will be increases. If system only doing some work, means work is negative, then internal energy will be decreases. If, for example, you are not absorbing, you are not taking any external energy, means Q is constant. Now your body is still doing work continuous, then automatically what happens? After some time in your body, internal energy will be less, means internal energy will be decreases. That is called work done. If Q is constant or Q is zero, work done by the system, work done by the system decreases the internal energy. If Q is constant, work done on the system, work done on the system means system, on the system some work is going on, then it increases the internal energy, increases the internal energy. Okay, this second condition we have to remember. Let's see in third one. If delta E is zero, means when delta E, internal energy will become zero, dear students, in cyclic process. If delta E is equals to zero, then what is the relation between Q and E? Q and E, negative relation. If Q is equals to minus W, you are writing like Q is equals to minus W, or minus Q is equals to W, like that we can write. If Q is equals to minus W means Q is equals to minus W means if Q is positive, then work is negative. If Q is positive, then work is negative. If Q is positive means the system absorbing heat, then the system absorbed heat is equals to work done, means work is negative means work done by the system, work done by the system. If Q is reverse, if minus Q and plus W, Q is negative and work is positive, then the system released heat, the system released heat is equal to the work done on the system, is equal to work done on the system, because work is positive came. Work is positive means you have to remember, already starting only I said work positive means work done on the system, work negative means work done by the system, work done by the system. Okay students, these are the main important conditions according in first law of thermodynamics. Let's see next important one is internal energy. Okay, what is internal energy? Let's see. And internal energy already is extensive property and also state function we discussed. So what is internal energy and importance of internal energy and change in internal energy, how to calculate, and some important points regarding to internal energy, enthalpy, entropy, Gibbs free energy, all we need to discuss based on that second law of thermodynamics, and some we need to discuss in this chapter. Okay, let's see internal energy. Internal energy means it is defined as the sum of the all types of energies. Sum of the all types of energies means potential energy, kinetic energy. Those all types of energies for a particular substance at given temperature is known as internal energy. That internal energy may be in the form of chemical or electronical or mechanical or any type of form or any type of energy. It is defined by E or U. It can be changes. That internal energy how can be changes, dear students? The internal energy will be changes by passing heat into the system or passing heat coming out from the system. Internal energy can be changed. Heat enters into the system, heat will be released from the system, or work done on the system or work done by the system, work done by the system, or matter enter into the system or matter leaves from the system, then the internal energy will be changes. Internal energy will be changes. Okay students, next the internal energy is an extensive property. It is also state function and it is also state function. Now main important point that these internal energy, enthalpy, entropy, Gibbs energy, these exact values or absolute values we cannot calculate, but change in internal energy, change in enthalpy, delta E, delta H, delta S, delta G, we can calculate. in a system. We can calculate in a system. Okay, students. So it is impossible to determine the absolute value of internal energy of a substance or internal energy of a system. But change in internal energy delta E can be determined, or delta E we can calculate. So what is the definition of delta E and how to calculate delta E? Let's see by using first law of thermodynamics. Take first law of thermodynamics, and Q is equals to delta E is equals to Q plus W. Q plus W, it's very clear. Now W is equals to minus P delta V. Okay. Now then Q is equals to, if Q is equals to delta E plus P into delta V at constant volume. At constant volume means delta V is equals to 0. At constant volume, this value becomes 0. Then P into delta V is equals to 0. Okay, P into delta V is equals to 0. Then Q is equals to delta E. QV means, what is the QV, dear students? QV means at constant volume, amount of heat. Amount of heat is equals to internal energy delta E. Delta E is equals to Q. Means how to calculate delta E? Delta E definition means at constant volume, the amount of heat absorbed or amount of heat released by the system is equal to change in internal energy. Means volume of the system is constant, then the amount of heat absorbed or amount of heat released is equal to internal energy of the system, is equals to change in the internal energy of the system. So internal energy change for any chemical reactions, the internal energy change is equals to EP, means energy of final products, or energy, internal energy final minus initial. Final means here P for a chemical reaction, energy of products minus energy of reactants. For exothermic reactions, delta E is always negative because the energy of reactants is more than energy of products. For endothermic reactions, why, dear students? So here simple logic, for any chemical reaction, delta E is equals to EP minus ER, the energy of products minus energy of reactants. Okay, exothermic reactions means Q is negative. Q is negative means delta E is also negative. Delta E is also negative because both are same signs. If Q is negative means the amount of heat released the system means Q value. If system releases heat means Q is negative means release heat. Release heat. Then internal energy delta E decreases. Delta E is decreases. That's why delta E is equals to negative. Delta E is equals to negative. Okay, students? Yes, ma, bhai. Listen carefully. So, for any chemical reaction, the delta E